Hello everyone, welcome back to Coding Charms, and in today's video we are going to be solving the problem maximum happiness of selected children. In this problem we are given with an array of happiness of length n and also a positive integer k. There are n children standing in a queue where I child has happiness value of happiness of I. And what we want to do, we want to select k children from these n children in k turns. In each turn, when you select a child, the happiness value of all the children that have been not selected till now decreases by 1. Note that happiness value cannot get negative, gets decremented only if it's positive. What we have to do? We have to return the maximum sum of happiness values of the selected children you can achieve by selecting k children. So to summarize, we are given with a set of children with happiness value. We have to pick k children and we need to get maximum happiness. But the twist is each time we select a child with some happiness value, all the other children's happiness value gets decreased by 1. Let's take a look at the example. So we have 1, 2, 3 and k value is 2. Firstly, we select the maximum value and then everything else gets decreased by 1. So this becomes 0 and 1. And then we select 1. So it will be 3 plus 1, 4. And then here we have k equal to 2 and the happiness is 1, 1, 1, 1. So we select 1 first and then everything else becomes 0. And so we select 0 and 1 plus 0 is 1. Next we have 2, 3, 4, 5 and k value is 1. So we just select 5. Let's see this example with some other k value like 4 or 3. Let's say k value is 3. In that case, firstly we select 5. Then everything else becomes minus 1. So 2 minus 1 is 1. This will be 2 and 3. 1, 2, 3. Then we select 3. And then the other two gets decreased to 0, 1. And here we take 1. And we have selected 3, 5, 3, 1. So this will be the answer. 9 will be the answer. So this is how we have to do. If you think about it, if we just forget this paragraph for a minute, this problem essentially becomes to find the k greatest elements in an array, right? That is a famous LeetCode problem. To solve that problem, we can do two things. One is to sort the array or use the heap to get the k greatest elements. So we can apply the same logic here, but the only thing we have to do is we have to subtract 1 each time we select some value. So each time what we are doing minus 1 for all the other elements that are not selected. When somebody gets selected, we do minus 1 for all the people who didn't get selected, right? So every time we do minus 1, and we know a set of numbers or children who are not selected. So instead of doing minus 1 in each step, I can just have a count value of people got selected, because that's when we do minus 1. And whenever I am considering this guy, considering somebody who is not selected, then I will just separate. This count will be number of turns that we have completed. So whenever I consider somebody who is not considered so far, I will decrease this count. If suppose the happiness value of the person who hasn't got selected, when I am selecting him, I just do count, h minus count. If this is greater than or equal to 0, then we consider it. If this value goes negative, then we just consider 0. I think this will be more clear once we go to code. So let's code it up. For this solution, I'm going to use a heap approach. So let's define a heap priority queue. It will be a max heap because we want the maximum elements. Um, let's have a count value and one to get the result. And then over, we have to iterate over the heap. We have to iterate over the happiness and add it to the heap. So happiness, max heap dot push h. Now we have all the elements in the heap. What we have to do now, while not max heap dot empty and k equal to greater than 0 in k terms, we pick the k children. So the child that we have picked, his happiness will be max heap of top and max heap dot pop. Now, um, now if this is not, if we don't consider this, then here we just add it to our result h, and then here we return the result. Obviously, we have to do k minus minus. Since we have to decrease the count, when we select an element, we do count plus plus, and when we are considering a person, then we have to also decrement count. And if this is greater than or equal to 0, we consider this h minus count. Otherwise, it is going negative, so we just consider 0. Yeah, I think this looks good. Let's give it a run. It passed all the sample tests. Let's submit it. Okay, I think this should be long. There you go. What will be the time complexity of this approach? When we add all the elements to the heap, the time complexity will be O of n log n, because it takes log n time to add an element to a heap, and we are doing it n times, so n log n. And here it will be, we are iterating over k times, and we are popping from the heap, so it will be O of k log n. So total it will be O of n log n plus O of k log n, which we can say O of n log n. So it will be O of n log n, and the space complexity is, we are using a heap, so it will be O of 1. I think that's all for this problem. I hope you have understood it. If you did, make sure you hit that like button and don't forget to subscribe Coding Charms for more of this problem solving content. See you in the next video. Till then, take care. Bye-bye.